One thing we would do to determine if an equation was balanced would be to count how many atoms of each element are on both sides of the chemical equation. So when I talk about sides of a chemical equation, there's two sides. On the left of the arrow, we have the reactants, and on the right of the arrow, we have the products. So the law of conservation of mass says that we cannot create or destroy matter in a chemical equation. So when we write in a chemical reaction. So in a chemical reaction is represented by a chemical equation, which I have here. So a balanced chemical equation will show that you have the same number of each type of atom on both sides of the chemical equation. So let's take a look. So if I first looked at hydrogen, there is a coefficient right here, 2. So the 2 multiplies through the formula. So 2 times H. So there's 2 hydrogen on this side. Then if I come to the product side here, there's also 2 hydrogen. Then if I look next at the chlorine, so the 2 here as a coefficient will distribute through the formula behind it. So 2 times 1, there's also 2 chlorine. And on the product side, we have the subscript, which also tells me there's 2 chlorine. And then finally, the last element in this chemical equation is calcium. And so on this side, there's 1 calcium. And then on the product side, there's also 1. Even though there's a 2 next to the chlorine, since there's not a parentheses, that 2 only goes to chlorine and not to the calcium. So there's 2 calcium. So this particular equation is balanced because when you compare the number of each atom on the reactant side to the product side, you have the same number. In the circumstance where you did not have the same number of hydrogen, for example, on both sides, or chlorine or calcium, so for example, on one side, the reactant side, say you had 1 hydrogen, and then on the product side you had 3, then that would not be balanced.